Hi, and welcome. Today we are going to talk to you about composable internationalization API in JSX and React that we have built at Cora. We are going to go over introduction first, then we're going to talk about the problem we had recently when we were migrating our front-end stack to React, the solution we built and internal design of that, and the learnings from this project and the results we got. My name is Benam, and I've been at Cora on the internationalization team for the past 3 years.
And I'm Chris. I've been at Cora for about 4 years, currently on our product platform team, but over the last 3 or 4 years, I've been working pretty heavily on the internationalization side and translation.
So internationalization at Cora became kind of mainstream in 2016 when we started adding new languages. And in the short span of 3 years, we added 23 languages in addition to the English, taking Cora to 24 languages. And the internationalization team have been generally responsible for making sure the interface is internationalized and the translations are basically available and delivered. Also for the growth of the community and supporting internal teams with their text processing needs on the server side. Later in 2019, very recently, we basically started migrating our Python-based front-end that was using the homebrew Web Node 2 interface template system, interface build system to React and TypeScript. For this migration was for various reasons, especially to improve user experience and the speed of the product. You can see like how the problem is totally changing the internationalization needs, because we are going from an old server-side rendering system to something that is almost all rendering on the client side. So we need to basically rethink our API needs in this situation and figure out how we can reuse the existing tooling that we have and existing localization system we have, while actually taking our internationalization API to the next step and improving the system as a whole. This is a very high level, poorly designed graphically the overview of the localization system at Cora. We hire for designers, by the way. So you can see that what we're going to talk about mostly is good on the interface side, which is the blue section on the left-hand side, where rendering is the main job of the internationalization API. And at the same time, we also have proper logging in place to monitor how things are going. And queuing is the part of the system that we decide what needs to be translated and how urgent it is, and like prioritization of the translation needs. We use an external translation management system, which basically there are different teams responsible for different languages, and our localization team is in charge of managing translations and these teams. And we bring in good translations in. We filter out the bad ones and ask for improvement. And then we store all the valid translation in our database. And later we package them and deploy them to the interface. So what is the problem we want to solve? We're going to look at the expectation of the internationalization and translation system at Cora, and also what kind of open source and solutions were available to us when we were working on this. The product requirements are the most important part, which is the first thing is that this API needs to be able to handle the current and future languages of Cora. And we already have a diverse set of languages by the time we were starting this project, including CJK, from the CJK family, the Japanese language, many languages of India, and also right to left languages, which Arabic and Hebrew specifically. And one of the things that is kind of a bit unique on our product space is the fact that we do have product experiences that require switching language in the middle of the UI, switching the interface language even, and like changing, talking to our user, to our viewer in another language, and that is basically the one side of the reason we needed a multilingual text support in our API. And another part is that sometimes we are not even changing the interface language that much, but we have, like, for example, if we are in a Spanish on the Spanish Quora, we still have the Spanish sentences, but the content could be coming from English, Arabic, Hebrew, Japanese, because basically we are relying on this on our large multilingual user base and these product features that basically merge different languages together to get all languages and to expand how knowledge is generated on the internet in general. So that is why the common patterns of dealing with strings and messages to some level were not working for us. And this is a problem we solved easier on the server side with our old like homebrew stack. But dealing with this on the React side was more complicated and also to some level more limiting on our choices for the open source library to use. On the localization system side, we had expectations such as keeping costs down, and one of the general things we have been doing in this time has been to avoid paying the extra cost for technical translation and using professional translation that is not necessarily like trained or even like specialized in translating interface languages, which usually come with complications and like these things that are called usually like branching. Basically, you have one template, one message that can branch into many different versions depending on the situations, depending on the context, contextual variables of the template. So this is also more important for the regions and languages that Quora is going into. Like it's gonna be harder for us to get quality translation if we have a requirement for technical translation for some minority languages. The minority languages in terms of like online minorities, the languages that are less available, there are less resources available for them online. While the user base is actually huge, and like and that's the reason we are actually like we think it's important to grow Quora in that area. And generally we want to pay for the translation we need, and so we have this translate what you need motto. As well as we wanted to also maintain our agility in the localization process, meaning that we want to be able to review messages and track where they come from very easily and very rapidly in the development process, while actually keeping the human supervision also minimal. Everything should be work. If we need to see something, we should be able to see it as soon as needed. And on the developer experience side, we set these expectations that we want to make sure that simple things are simple and the complex things are possible and understandable. This basically made some part of the design even easier for us because we knew where to start with to keep things simple, and then from there we grow. We let the project to grow into a direction that it needed to go to support the complex situations. We also wanted to make sure that our syntax overhead is minimal, and like the kind of like terms and symbols that people need to see on the code, developers need to see to deal with them. Those things should be minimal. They should stay familiar. They should kind of be easily understandable and visible. More importantly, the idea is that if developers, like whether it's an engineer or a designer writing interface code, they should easily see what is the thing that they're sending for translation, they're marking up, and how it can affect its surrounding, and what it's entailing, what it's including inside it. Another big important part of this experience we wanted to build was to make sure that our formatting mechanisms and our template system is extensible in the meaning that we don't have to go and touch the core library to be able to support something new for most of the cases. And this is something that we considered important because our product grows in different directions and different teams need to build new things. And we didn't want everyone to depend on a single team developing things for them. So we looked at some of the open source solutions to see how if we can leverage any of those to address our problems. Of course, React i18n is one of the popular projects out there. It has some of the legacy approaches, I would say, to template management, including having key-based lookups and having namespaces, which do fit well in the older localization system design. But I think they are less needed in the more agile systems to some level, and they are actually they have this approach that okay, you set your namespace, in every module where you are using the translation API, you set the namespace, and we're gonna package things based on that namespace later. Most of the time, that's how people use it, apparently. And also, but on the rendering side, it's featureful. You can basically change the language of the page. For the whole page, you can change the language without actually the page needed to be reloaded, which is a very nice thing. And another project we looked at was the Facebook's FBT project, which is a little, it seems more modern in terms of the integration with the localization system. It has hash-based identifiers and doesn't try to define projects that much, as it leverages from a static analysis, from build time processing of the code using Babel plugins, and uses that for extraction and deploying and packaging things together, and even deploying translation with the packaged JavaScript code. That's very nice. There are many good benefits there, but also there are some limits coming with it. As we mentioned before, what we need to be able to support multiple languages. That wouldn't be easy to do in that situation. There's also the JSX template syntax, which is more prominent here, although at the same time it's also more verbose, and you can see that for example, when you define a parameter, when you want to put a user's name, you have to say that I have a parameter here, there's the variable name, and this is how you get the gender and everything like that. And this is something that, and the fact that these pieces of the template are not composable means that you have to basically copy paste something like this all over your code base whenever you are referring to a user. So, and you, from what it looks like, if you want to actually go and expand this, you have to go and touch your library to support this. So the solution we built instead is that we are basically, first we're going to talk about the syntax part of this and how the semantics of this syntax work internally, and then we're going to talk about how composition of templates work in this system with this syntax. The syntax splits in a few areas. We're going to first look at the simple templates, stuff that basically is just a sentence or something like that. How we handle contextual information, which is important, especially when you have your source language inside the code. And also branching, how we handle branching, how we deal with parameters, and also containers, which is something a little more new to a template system that we're going to talk about. Simple templates are handled as we expect, simply. So with all developers need to do excuse me, all developers need to do to handle a simple sentence like hello world, to mark it up to be translated and to get the translation, and when this is being rendered, is to put that sentence inside the translate tag. This is also this is showing us. You can see here that basically the English, which is the source language in our code base, is being hard coded here, and this is what we're gonna actually package into the JavaScript code when we are compiling our like TypeScript to JavaScript and like minimizing it and everything. So this is going to be the ultimate fallback for everything. If anything goes wrong anywhere during the translation step, this is what is going to be used. And this is a nice behavior to some level, because anyway, translation systems can break. Translations can, something can go wrong, like in hand-in translation, especially when you have a more of an agile system, a very fast developing and changing system. So it's good to always have some fallback instead of bailing on user. And so that was the JSX handling, which basically translates into JSX elements, which would translate into kind of some HTML rendering depending on the situation. It could become basically a plain text kind of, or it can go inside a button or some heading or something. Sometimes you also need to make sure that you're getting the string value for something, because for some template, because you want to pass it on to some API that expects a string as input. So this is going to be handled by one function called plain text translate. And while you are doing this, basically the translate part is kind of redundant, because we already know that whatever goes inside this should be translated. So it's even okay to drop the translate markers around the template at this point and just rely on the simple React fragments. And even if you don't need to actually compose stuff inside that JSX, which we're going to talk about later, you can even fall back to using just a simple string. So this becomes a simple function called plain text translate hello world for me. So contextual information is more important when we have the language in English coded as inside the interface code and being used to generate our unique identifier for this template. For example, it's commonly known that like for something like a question could be a verb or a noun in English. So we need to basically tell our translators which use case of that is. So we support this context property on the translate templates, on the translate component, which allows us to have any free-form description or even use some predefined markers. Using the predefined markers has the benefit that if all you need is question as a noun, all developers, all engineer and like designer would write the code the same way. That we're gonna reduce the number of templates generated. We're gonna reduce the number of translations needed. And then that was the basic like syntax of the templates. Now how we handle branching, which is very important because languages are complex. So we have also this this component that is called plural translate, which taken a value, it knows you tell it how to branch the template based on the value, based on that value and kind of the plural form property of that value. How it works is that for English, as you know, plural forms are limited to one another. We also support a 0 in this case, because actually having a different template for the case of a value, some count being 0 in your interface is actually very common. So we saw that this is a common pattern. We added this to our API because it would help with the velocity. Enumerations are another kind of branching, which is basically when you have a few possible cases for the For some situation, usually you have a value of enum type, and you are dealing with that. You can basically enumerate over those, and as you can see, all of these are properly type checked, and you can make sure that like you're not having any typos in the code while developing these templates. You don't have to rely on even getting all the way to your static analyzer, your build system or your runtime to check the validity of this code. TypeScript would even actually check a lot of these templates for basic sanity checks. There's an option here that also you can define a default branch for enumerations and say, okay, I'm a special. I want this for case A. I want that for case B, and for everything else, I want this third option. This is that's usually where branching stops in template system. But soon we realize that it's actually useful for our developers to have access to the JavaScript ternary branching as a form of at least one other form of branching. We may add other support for other forms of branching as well. The other ones haven't came up that much yet. But this is the idea generally that now that you have stepped into this step that basically you are looking at this JSX syntax and you are at runtime or at build time, you are basically analyzing it. Just having a component with some objects as its input, we don't have to be limited to that. We can actually support the basic language features like the JavaScript ternary. This is used more in cases when you have some binary option enabled or not. You don't have any enumeration defined for it, so you don't need any type check for the enumeration. So it's a Boolean case. If this, if the action happening right now is editing, use the phrase update. Otherwise, fall back to submit. For after branching, if we get to parameters, and for entity parameters such as a username, user being an entity, username is the way we want to render a user's name as they have told us. So what happens here is that you can see that all the information needed for this component to render itself is already given to it as the forms of how we handle our information and pass information through prof down the layer, down to the components. So you can see that we don't need to, for example, when we support gender for usernames, we don't need to add another gender option here and tell this component what its gender is. It can actually know its own gender by the data it's giving, and it's defining internally, and it's inheriting through the common process. There's no change needed in the template syntax. However, you have options per property for this component that lets you customize the rendering of this component, which is what you actually usually need in rendering of templates. You don't want to have to deal with you don't have to copy like logic and like create multiply number of components you have just because you want different like formatting options for them. You can see that it works very similarly for language names, for example. And it's again very similar for formatting values such as numerals and dates and anything that could be more handled in the i18n internally. There's no like entity data about it, but it's all like basic values and local information that is going to result in the output. Component definitions. So you see that components are basically like they can be used inside the template and they would become parameters. Those components would render easily as a regular React component without being included inside the React translation template as well. That's because they are basically built as React classes. All we do is that we use some special parameter types to basically add some marker information to this component so that later when we need to know how to render this component inside the template. We know how to render the JSX version properly, and we know how to render the plain text of it. So it's a kind of we are basically like specializing React component, React class components to be used as parameters, and those would be the only kind of React components that would be used as parameters. One other class of React components that can be used inside templates is what we call containers, and those would be basically whatever you use for styling text or adding behavior to text in the middle of templates. It includes the basic HTML tags such as A, B, like string, anything that is kind of text formatting, or even more complex components such as like our link component. These things can directly also go into the template and basically add behavior to the text while the user sees this whole thing as a text, while the translators translate this whole thing as a whole. We know that which parts of it says draft, and we link that, and we basically maintain all this behavior defined by this React component, even through the translation. It works the same in English versus if even the wording is different in some other language. Now, composing templates. What does it mean, and like why do we need this? Composition is this concept of reusing your basically building more complex things by gluing things together instead of inheritance, instead of inheriting behavior or like code implementation through inheritance. Composition is heavily used on React, and it's one of its core concepts that you can compose and specialize components as needed to build something new. And that's what we are also doing in the translation system, because it's a great pattern to reduce redundancy in the code base. And we actually noticed that from our experience on the Python web node stack, we noticed that there's a lot of pieces of the templates that can be shared, and developers actually feel more comfortable sharing those parts instead of keep writing them. So remember previously we talked about like some user name rendering parameters need to be copy pasted in some other template systems. Well, when you get to other parts of it, for example, how to render some enumeration, or how to make some piece of a some commonly used phrase, you're having access to something, or like this was done, or this many of that object. These kind of patterns are very common in interfaces, and actually when you want to make an interface that is more social and more personal, you need to have more of this kind of text to talk better to the audience. So that's why we basically invested into making our templates composable, which lets us basically create the new tools. Every team themselves, every area of the product can create their own tools as needed to reduce the number of reduce the size of templates that they write, and reduce the bugs introduced by it, because like they keep one copy of it, don't repeat themselves, and review that once, and they're good to reuse it after that. The details of it is that it's basically very simple. Again, it's the composable templates. The templates that can be composed are basically any React component that is returning some translation. As an example is that you want to say person or people. So how would you make something? This is from our code base that we needed such a thing. So someone wrote this React component. This is a functional component. Taking the count, it decides if it should say person or people, depending on that count. This is something we call a text component. Basically, all it's responsible for is to take some parameters and generate text for it. The other way to actually compose, benefit from composing templates is when you build some behavior A, and now you want to expand the text of it. So you create component B, reusing A and expanding its text, generating basically marking up a larger template around it. and basically inheriting all the behavior that comes with A, as well as not inheriting in terms of like behavior, getting all the parts built into A while expanding it and adding some new text to it, for example. Here's another example of like how a text component is used. This is a little more complex. Basically, this one is a text component that is only doing some enumeration for some access level. And this is the singular form. So you see an admin, a moderator, a contributor, a follower. And how you would use it in a template is that this user was invited to be that level of access, full stop. And you can see how such a text component can be used over and over, because it's a very, very common pattern to talk about access to some object when you are basically managing it. So you have all these differences that let you reuse this kind of thing. Now I'm passing it to my colleague, Chris, to tell you more about the internal design and the rest of the talk.
All right. Hi. Yeah. So I'm Chris, and I'm going to talk a little bit about the internal design of what we do in order to support the API that Benham was just describing. There's a few things I'm going to go over. First, I'm going to talk about our unit of translation. So this is essentially the unique object which defines the translation which we are sending up to translators to translate. Then I'm going to talk about how at runtime we process the JSX that's being passed into this this template tree, which we use for translation. And then I'm going to talk about some of the build time tools and static analysis tools that we built in order to improve the collection of all of the template trees that we need for translation before they even get deployed into code. So first I'm going to define what I mean by the template tree. The template tree will uniquely define a single translation that we want to show in our product. Translators directly work with a serialized version of this object, and they can be uniquely identified by just hashing that serialized string into what we call an LID, stands for localization ID. The template tree itself is made up of 3 different types of nodes, either a string, some JS objects, which will represent the containers and parameters that Benham was mentioning earlier, and then also an array, which can itself contain one of the other types of nodes. So the most basic version of this, so if we just have that string, welcome to Quora, the template tree that's generated is literally just that string, welcome to Quora, you can see here. This keeps the simple case very simple. All the cases where you don't need any composition or parameters within your translation, the template tree ends up being very simple and very easy for translators to work with. For the example where you have a container object, so in this case, somebody's trying to say the string your profile with a link to their actual profile. In this case, the template tree that's generated is a JS object with 3 different fields. First is the type field. This defines specifically what this type of object is. In this case, it's a style. It has an ID, which will uniquely identify it in the parameter map, which I'll talk about a little bit later. And then it has a children field, which itself is another node in the template tree describing what is inside this container. So in this case, it's the string your profile. So the parameter map is something that we use in order to keep track of what each of these objects that we create is, so that when we reconstruct the translation later, we know what JSX elements to put in their place within the translation. They can be found by looking at the field within the parameter map that matches the type, so in this case style, and then indexing into the array using the ID. So you can see here for style 0, we go look in style, we look at index 0, and you can see here's the A tag, which represents this container represents. For parameter objects, which are even a little more simpler, so in this case we have some username here. Username is going to have been decorated, as Ben described earlier, with user entity param object, which allows us to identify that, hey, this parameter doesn't need to be translated. It needs to be replaced directly in the template tree. So in this case, we replace it with this object with just type user and ID 0. In this case, there's no children because there's no subtree under username. And then in the parameter map, just as with the container parameter before, you can find the JSX element that this represents. The last, of course, is array node. So this is when we want to have sort of sibling elements next to each other within the template. So in this case, someone's trying to say welcome to a user. So in this case, it's just an array with the first element being a string node and the next one being the object node that user name represents, and then the parameter mapping it there. So in order to keep the template trees unique, there are a couple of normalization invariants that we want to make sure we maintain when generating these node trees. Basically, we want to make sure there aren't two node trees that represent the same translation that have slightly different formats. So there's these 4 rules that we apply. First, array nodes must have a length greater than 1. If you have an array node with only one thing in it, you can just replace it with that thing instead. Array nodes cannot have an array node as a direct child. So basically, if you have an array with an array directly inside of it, just flatten those arrays into one array. Array nodes cannot have adjacent string nodes. So essentially, if you have an array node with 2 strings in them that are immediately adjacent to each other, just concatenate them together into one string. And then container object nodes cannot have a single object node as a direct child. This one's a little less easy to see, but essentially if you have 2 container tags right next to each other that are both wrapping each other exactly, it's easy to just replace those with a single object node instead of having 2 object nodes inside of each other. So essentially we just flatten those 2 nodes together into one child node. All right, so now I'm going to talk about how exactly we generate these node trees at runtime. So there's basically 3 different steps that we need to do at runtime. First is that that conversion there, where we have the JSX, which developers have written, and we need to turn it into some template tree and the matching parameter map for the variables that are passed in. Then we need to look up the matching translated tree. We do this using the hash and the LID that I mentioned before. And then we need to recombine that translated tree with the parameter map that we generated before into translated JSX that we can then pass on to React to render as it would any normal components. So in order to do the conversion step, we recursively iterate over all the children of the translate element. When we run into strings or numbers, those are just converted directly into string nodes. Null nodes are actually just ignored. If we run into a custom parameter or a container component, so these are the things that are marked with those entity parameter decorators that that Benno mentioned earlier, then we convert them into the container objects. This actually also includes a hard-coded list of some base HTML elements, including things like A and div and B and I, because all of those we can just treat as containers. And lastly, when we run into any other kind of component, we will try to shallow render one step of that component and then recursively iterate over those components instead. This basically lets us perform a single step of rendering to see what that component represents, and really allows us to have this composability where you can reference components from other files without having to basically spell out the whole template every single time that you're using it. So here's a more complicated example here. So somebody here is trying to basically say your answer was upvoted by some user and 5 others, with some styling all around that, and also handling the case when the number is not 5. So just to point out how these are reflected in the template tree, if you look at the B and the I tag here, you can see that they're represented by a single style container node here with children answer. And then you can see in the parameter map, there's the matching B and I tags that represents. The username is converted into this user node, which you can see here in the parameter map as well. This A tag here is converted into this style node with children, which is itself an array node of other elements. And you can see the matching A tag here in the parameter map. And then this formatted number is turned into a number object node, which also has some extra information about the category of the number that's being used. In this case, the category for 5 is other. So once we have this template tree, we will convert it to an LID and look that up in the translations that we've deployed onto the client. So in this case, it gets converted to this other template tree, which is the translated version. It says su respuesta ha recibido un voto positivo por user y otras some number and personas. I'm bad with Spanish. This case is Spanish. So once we've done that, we then need to combine that translated tree with the parameter map that we generated earlier to create the translated tree. So in this case, what we're doing is we're taking each of the matching style, user, and number tags, looking them up in the parameter map, and inserting them into the translated tree to generate the translated JSX that we need. So here you can see that now we've perfectly created a translated version of this this text. One thing I want to call out is how important multilingual text rendering is to us. We have a lot of parts of our product where different languages are mixed together. Here's an example screenshot at the bottom where in this feed reason, we're displaying some names that are in sort of Latin characters that are being mixed in with Arabic characters, which is both a different character set and also direction. So in order to do this, we make sure that we isolate the parameters. So in this case, these usernames here, we isolate them using some HTML tags to make sure that they will render in the correct direction compared to the rest of the text in the sentence. Right, so now I want to talk about some build time analysis and static analysis tools that we built to help with this, this system. So there were a couple of goals here. We were coming from a system in Python where all of our translation logging was at runtime. So the only way that we could be aware that a translation was needed from the product teams or on the product side was if they were actually used in the product, which is not a great user experience. This caused issues whenever there was improper use of the API. We wouldn't know until after it's already in production. We couldn't figure out what needed to be translated before users started seeing it, so we would end up having untranslated strings in production for some time. So we wanted to make sure that we could move to a system where we could find all of the translations that we need at build time. So we did this by creating a custom Babel plugin, which we named Babel Shark because I'm bad at naming things. Babel itself is a JS compiler tool. It's pretty commonly used in the industry. It's commonly used for JS transpilation, particularly when when wanting to use ES6 syntax in JavaScript, but wanting it to run on browsers that don't necessarily support ES6. It's also one of the primary ways of using TypeScript. So we were using Babel as a static analysis engine where it does a lot of the parsing for us and allows us to work directly with the AST for the JavaScript. So the way the Babel Shark works is it parses each file separately. It can do these all in parallel. So parsing one file is not dependent on parsing another file first. And then for each file, it will look for translate elements and create what I call a template tree builder, which I'm going to explain a little bit later is a slight difference from a template tree. For each translate element, it tracks these because we need to know all of these templates because those are the ones that we need to translate. But then we also look at all of the exported components in that file, and we also try to generate a template tree builder that represents that component. That's going to be necessary later for when we have components that are being composed across different files. If we have some component that's being used in a translation in a different file, we need to know what the template tree for that builder or template tree for that component is. So the template tree builder is basically just a little helper class for building and tracking all the template trees that map to a particular part of the block of code. It is built off of template trees, but essentially is just a way of maintaining a branching of a bunch of different template trees that can all exist from a particular part of code. It has a debranch function, which will debranch out the template tree builder into all the possible permutations of template trees that could exist from this builder. And those are the ones that we actually send for translation. So there's 7 different node types for the builders I'm going to go over. The first 4 of these are actually completely analogous to the same nodes for template trees. So string nodes, array nodes, parameter nodes, and container nodes. But there's 3 that's unique to the build time analysis, excuse me, which I'm going to be talking about. There's the unresolvable node, the import node, and the branch node. So the unresolvable node indicates something that we're not able to statically resolve to a template tree. This basically is a problem. If someone's trying to do something within Translate where we can't figure out what the string you're trying to translate is statically, that's when we're going to be getting this unresolvable node, and it will raise an error to the developer. So in this example here, we have somebody who's trying to translate excuse me, a field directly from the props within their sentence. This is unresolvable because there's no way for us to possibly know what those props are when looking at this translate call. So we need to make sure that we prevent developers from doing that. When we're looking at components and looking at exported components and seeing what their template tree builders are, those are okay to be unresolvable. In fact, most components are going to be unresolvable, but as long as they're not used within translation, that's not a problem. The next is the import node. So this indicates some component that you're using that exists in another file. Since we're looking at the files one at a time and not relying on any other file already being parsed, we need some way of representing that this component exists in a different file. So the import node here basically just stores saying, hey, we're importing some other component. It exists at this path with this name, so that after we parse all of the files, we can replace this import node with the template tree builder that we found from that exported component in that other file. The last one I want to go over, excuse me, is the branch node. Excuse me. So there's, in this example here, we have somebody who's branching on saying either admin or contributor based on whatever the role type that they're trying to use here is. So the tree builder here basically maintains all of the different branches which this string could represent. So in this case, it includes a branch for admin and a branch for contributor. And so when we call dbranch, that's the thing which is going to be taking all of these branch nodes and splitting them into their separate tree nodes and creating all of the different permutations for all of the branches. One thing I want to call out is not all of those permutations are things you're going to want. So that's what these reasons here are used for. And I'll kind of go over why we need those. So in this example, somebody's trying to say either space admins have unlimited invites remaining or space contributors have 5 invites remaining. But unfortunately, if we try to get all of the different permutations that could exist from this translation call, you're going to get these 4 strings here, which include 2 that are never going to actually be used because it's impossible for role type to be both admin and not admin at the same time. So we need some way of maintaining that these 2 branches are looking at the same object. So that's what these branch reasons are for. And so branch reasons keep track of basically the field we're looking at, what kind of comparison they're doing and what they're comparing to. And so then when we're doing debranching, we can look and we can see that we have 2 conflicting branches here where one says that role type is equal to admin and one says where role type is not equal to admin. And we can make sure that we don't include that permutation when we find those conflicting branches. So I want to talk about a couple of results and learnings that we found from creating this new API that we use. As far as our development strategy went, we first started with just the runtime processing. It started with just sort of a proof of concept, making sure that we could process templates on the front end, log them and look them up and reconstruct them. This is actually pretty quick to build, only took a couple of weeks. One of our concerns was the performance of actually rendering the templates if we had to be doing all of this conversion during runtime. It turned out that was actually not so bad. We were able to make a couple of improvements to make sure that rendering was still fast. There are a couple of challenges around some React features which you can't use directly within translation, like context providers, context consumers, and portals. Mostly that's been totally fine. We haven't had any asks from developers where they specifically need to use these within the text of the translation itself. They can be used within parameters, no problem, since we hand off the translated JSX to React to properly render those things later. For our build time analyzer, it took us a few more months to be productionalized. It's been pretty great for our system though, because it really allows us to do a lot more detection and at dev time and build time rather than waiting until strings are in production. It gives us a lot more control and visibility into those translations before they're needed. And it allows us to know exactly which translations we need to deploy to the client and when. since we have an understanding of which translations are used in which files, we can make sure that only the translations you need for the files that you need to render your page are the ones that we send to you. For developer experience, we've gotten feedback that it's been very easy to use, which is very nice. It has a very small API surface, which is very, very good. It allows reuse of a lot of the common template fragments. So we have a lot of different teams that are constantly basically switching between, let's say, contributor, follower, moderator, and admin based on what the role of the user is, and being able to just use the same component and not have to worry about which one they actually need is, creating their own component every time they're using it is very nice. It allows people to iterate also a lot faster on the copy that they need. It also helps that we are able to, with the static analysis, build a file which contains all of the information about all of the translations that are being used and what files they're in, which allows us to review templates a lot easier, allows us to review them during push rather than after they're deployed, and allows us to see all of the different template branches that you're going to need when you're creating them, so you don't end up with some large combinatorial. It also allows us to have a bunch of automated checks. Babelshark also does a check, which I didn't describe, where it makes sure that you don't have untranslated strings in your JSX. So basically times when people should be using the translation API but forgot to. So that's a very useful check, because otherwise we end up showing English strings to non-English users. We also have a bunch of strict type checks in place using TypeScript in order to enforce that whenever using the plain text translation API, that you need a translated string rather than just being able to pass in any old string. Using the build time analysis that we have, we also implemented spell checking to make sure that when you're pushing new code, that all the translations you're asking for are at least correctly spelled English, which is good. We also have started doing some recommendations of existing templates you can use instead of needing to ask for a new translation. Basically, like the common cases where somebody's only slightly tweaked the string without realizing that it's being used in a slightly different form somewhere else. We can recommend, hey, there's this string that is very similar to what you're looking for. Why don't you use that? We found that to be quite helpful as well. From the localization experience perspective, they like being able to review the templates before they're actually being used in production, which is very good for them. We have a Slack channel where we can see all of the new translations coming in here, so you can see some examples of new translations coming in from Babelshark. It tells you their status as well. Sometimes it tells you how many of them how many translations are currently missing, and sort of the visibility of the string that's being used. And it allows them to sort of prioritize their translation based on the product area that they're coming from, now that we know what file the translation is coming from, and sort of the visibility level of how visible they are within our product. So what's next? There's some product experiences that we don't currently support. We haven't, with our translations, needed support for gender. We kind of just instruct translators to translate things in a neutral manner, which has worked for the languages that we have so far, but is something that we'd like to be able to support in the future. We just haven't had a product need. We'd like to move towards some more build time code transformation itself. Right now, all of the build time analysis that we're doing is just parsing and reading of the files, not doing any changing of the files themselves. But one thing that we could do is we could basically replace those translate elements with some new code that can use the build time LID that we've detected to directly look up the translation during runtime. This would basically save us from having to do the JS template conversion at runtime and sort of speed up the process a little bit by sacrificing some build time costs. So that's it. It's great if you have any questions. We'll be answering questions after this. And yeah.
Thank you.